consider a discrete sequence. X1 of n is given. Let's say I have given 1, 2, 0, 4, 5. I have represented an arrow below 0, and let's consider another sequence x2 of n, which is given as, let's say, -2, comma here, -3, 2, 1, 4, and the index, 0th index is given below 2. Now, if we would like to find out x1 of n plus x2 of n, what should be the answer?
-1, -1.
So from both the expression, it is clear that it is starting at -2 index, isn't it?
Yes, sir.
So this is 0th index, right? This is 0th index, and this is -1 index. This is -2 index. This is first index. This is second index. Similarly, for the other sequence that is given x2 of n, this is the 0th index. This is first index, second index. This is -1, this is -2, index number -2. So if at all we would like to go for a plot of x1 of n, let me do it here. X1 of n. So if you take x-axis here and I take index n, and this, let's suppose y-axis here, and we are interested to plot this discrete sequence x1 of n, and assuming this to be 0th index. Similarly, I'm taking x2 of n below this so that it will be clear. So let's suppose this is 0th index and this is n, and we are interested to plot here the discrete sequence x2 of n. Now, based on the data that is given, you can see at 0th index what is value of x1 of n. It is 0. So there is nothing over here. At first index, let me put all the index here. That's it. This is first index, second index, third index, -1, -2, -3. Similarly, if I put here, this is 1, this is 2, this is 3, this is -1, -2, and -3, right? And based on the value that is given, x1 of n sequence, at 0th index the value is 0, at first index the value is 4. So let's suppose this is 4. I'm taking this as 2. This is 4. So at first index the value is 4, and at the second index the value is 5. Value is 5. At first index the value, or -1 index, the value is 2, and at -2 index the value is 1 plus 1. So this is the sequence. So this is supposed to, this is 4. So we say that this is 2, this is 1, this is 2. At first index it is 4, this is 5. This is plot of x1 of n, right? X1 of n happen to be a discrete sequence, and this plot is mentioned here. Now we would like to go for the plot of x2 of n. So x2 of n, you can see the 0th index here. So at 0th index, what is the value for x2 of n?
2.
It's 2, right? It's 2. So assuming this as 2, I've taken 2. And on the first index, what is the value? It is 1, right? And in the second index, the value is 4. At -1 index, the value is -3. So let's go for the negative axis here. So let's suppose this is -2, this is -4, this is -6, and right, this is 2, this is 4, and so on. Right? At -1, the value is -3. -3 is some up to here, suppose. It's -3. At -2 index, the value is -2. The value is -2. So if I write all the values, this is -2, this is -3, this is 3, this is 1, this is 4. Now, when we speak of adding this to signal, question is asked, what will be the value of x1 of n and x2 of n? Right? So let me write here. If I take index axis n, and let's suppose this is the y-axis. This is 0th index, first index, second index, third index, fourth index, -1, -2, -3, -4. We are interested to plot x1 of n plus x2 of n. At 0th index, can you say what will be the value?
2.
It is 0 here for x1 of n, and it is 2 here for x2 of 2. So sum of the two will be, the equivalent value is 2. Right? So if I take the y-axis, this is 2, this is 4, this is 6, this is 8, you can say. This is -2, -4, -6, and so on. Now add the value at first index, what you will get? At
5.
5.
index 1 is 4, another is 1, so we will get 5 over here. This value is 5. This value is 2. And at second index, what we will get? 5, 4,
9.
9. So it will be up to here. Value is 9. And at -1 index, you can
-1.
2 -3, that is -1. This is -1. And at -2 index, it is
-1.
so 1 -2 is -1. So how to mathematically express this sequence? If I write
-1.
this as x3 of n, which is equal to this 2. So x3 of n, we can represent in this way. This -1, -1 is 2, 5, 9. This is the origin, I mean, 0th index, 2. So x3 of 0 is. So if a sequence is given like this, we can represent the values in this way. Let's say we are interested to find out x3 of 0. What will be the value? It's -1. X3 of 0, what is the value? It's
2.
2. X3 of 1, it is 5.
5.
X3 of 2, it is 9. Similarly, x3 of -1, it is minus x3 of -2, it is
-1.
right. So any sequence, any discrete sequence is given, and the value of the sequence at a particular index. What are these numbers? -1, -2. What are these numbers? These numbers are the index points, right? So at this particular index, what is value of the sequence? X3 of n happen to be sequence. This is a discrete sequence. This is called as a discrete sequence. It's not discrete time signal present. There is no time here. You have n. So it is called as discrete sequence. The sequence value at different index points, right? At different index points, let's say x3 of 0, 1, 2, that can be extracted or can be known based on the expression of the sequence that is given. So x1, x3, x1 of n, x2 of n is given. We have calculated a sequence mathematical expression x3 of n, which happen to be sum of x1 of n plus x2 of n, right? Let's say if we are interested to find out uh, another sequence x4 of n, which is equal to x2 of n minus x1 of n, and we will do it uh, in this way, where if I take x2 of n, what is the value of x2 of n that we had taken?
-2, -3,
-2, -3,
2,
and
1, 4.
2, 1, 4.
1, 4. And this zeroth index was 2. And what is x1 of n?
1, 2, 0,
1, 2, 0,
4, 5.
4, 5.
5. And this was the zeroth index given. And in question, it is saying that to calculate x4 of n, which is a subtraction of these two sequence. So without drawing figure also, we can do it. That is one way of doing. Like you can visualize and do. So here, if I am interested to write x4 of n, so what I'll write, first write the zeroth index. So at zeroth index, this is 2, this is 0, right? We are subtracting x1 of n from x2 of n. So this is 2 minus 0, that is 2, right? So what will be the value of the first index? That is 1 minus 4, that
Minus
is minus 3. And this is 4 minus 5, that is minus 1. And on the minus 1 index, it is minus 3, minus 2. So
Minus
which is equal to minus 5. And here this is minus 2 minus 1, which is equal to minus 3. So this is the mathematical expression or as the sequence x4 of n, which happen to be subtraction of x2 of n and x1 is x1 of n, and it is represented in this way. Okay? This is one way of it. So continuous time signal, discrete time signal, we have seen the sum of signal and subtraction of signal. So we have seen addition of signal, we have seen subtraction of signal. And another important thing that we will see here, which is called as scaling of signals. This is an important mathematical uh, stuff that is applied on the signals, scaling of signals. We have two types of scaling because we can represent signal with help of x-axis and y-axis. We can scale the signal with the x-axis parameter or the independent value parameter, and we can scale it up in the y-axis also, right? So let me take one small example. I am taking one signal x1 of t, right? And diagrammatically I will represent. So this is time axis. This is time axis, and let's suppose this is y-axis or amplitude. So this is I'm taking as amplitude A, and this is the zeroth index, and the signal is represented something like this. It exists from -1 to +1. T is equal to -1 to +1, and the amplitude of the signal is, let's suppose, 1. Amplitude of the signal is, let's suppose, 1. And I would like to scale the signal in amplitude. I would like to scale the signal in amplitude. So what I'll do, I have x1 of t, and I'm going to multiply a scaling factor. I'm going to multiply a scaling factor. Let's say the scaling factor is a naught, small a naught. So I have multiplied a scaling factor here. So we will see the condition if a naught can be greater than 1 or less than 1, and how it impact the signal representation. So the signal x1 of t, how it will look like if you scale the amplitude with a factor a naught. So let's consider if a naught is greater than 1. If a naught is greater than 1, and I am taking let a naught is equal to 2. So what will be the signal expression? So if you mathematically express this x1 of t, what we can write? X1 of t is equal to 1 when t lies between -1 to +1, or 0 otherwise for rest value of t. So this is the mathematical expression, and this is the figure that we have. Now we would like to scale the amplitude of x1 of t with a scaling factor a naught, and if a naught is equal to or a naught is greater than 1, and I have assumed the value of a naught to be equal to 2, what will be a naught into x1 of t? So, and what will be the mathematical expression also we will note down. So let's take this as the x-axis this time, and let's suppose this is y-axis. Here I take amplitude. So at 0th index, what was the value here? You can see from -1 to 1, the amplitude was +1. Now from -1 to 1, time will not be changed, isn't it? So here there is no change that, or no scaling that has occurred at this independent variable. Only scaling took place where? Here at a naught, right? Amplitude part. So amplitude is scaled a naught times. So amplitude, which was 1 earlier, will no longer be 1. So it will be equal to a naught, right? And a naught value is given as 2. So the amplitude will become 2, right? This is 2. And the other things will remain as it is. So what will be the mathematical expression of the signal?
2.
x2 of t, let's suppose I take it as x2 of t, this whole thing, right? So x2 of t, which is a1 into, sorry, which is
Sir,
a naught.
the time interval should be in the range from -1 to
Minus
1.
1, sorry, it's -1 to 1. It's wrong. It's -1 to 1. Time will not change, it's -1 to 1. Right? So a naught into x1 of t, that can be mathematically expressed as the value is 1 into, or right like this, is a naught into 1 for t lying between -1 to +1 and 0 otherwise. So if the value of a naught is greater than 1 here, and we have seen a figure, if the a naught value is less than 1, what will happen? If I take
2.
a naught is less than 1, and I assume let a naught is equal to 0.5, or you can say 1 upon 2, so what will be the figure? If I draw it here, this is time axis, and this y axis is 0. So you will see that the amplitude, this point was 1, this is 2, and this is 0.5, right? 0.5. So a naught is 0.5, and for the interval -1 to +1, the signal amplitude scales down. Scales down. So what will be the mathematical expression? This is this expression is also valid. I can write a naught into 1. So in this case, it is 0.5 into 1 is equal to 0.5 when t lies between -1 to 1, or 0 otherwise. So if you take this signal as x4 of t, and I write it as 0.5 into x1 of t. So this is the mathematical expression of x4 of t. So, is it clear?
Yes,
This
sir.
is this is called as amplitude scaling, right? So we were discussing scaling of signals, and what we seen just now happened to be amplitude scaling of the signals. Now, if we go for time scaling of the signals, let's suppose I would like to go for time scaling of signals. We are dealing with continuous time signals, right? So time scaling of signals. So if x1 of t is given, if x1 of t is given and the expression is given in this way, let's take the same signal. The value of x1 of t happen to be 1 when t lies between -1 to +1 and 0 otherwise. It happened to be the same signal that was considered in the previous example. And if I plot it over here, you can see this is time axis, this is a y axis, x1 of t, and we take this is 0th index. The signal, if I take this as -1 and take this point as +1, in between -1 to +1, the amplitude is 1. This is the signal that we have considered, and we are now interested to time scale the signal. Let's suppose I have taken another signal x5 of t, which is equal to x1 of at or a1t, x1 of a1t. I have used the scaling factor of a1. So either a1 can be less than 1 or greater than 1. We will take up both the examples. So either a1 can be less than 1 or a1 can be greater than 1. If a1 happen to be less than 1, how the signal that is represented over here, how it changes in time, and if a1 happen to be greater than 1, how it changes in time. We will visualize both and we will represent both mathematically. So let's suppose a1 x1 of a1 of t, and I take a1 to be 2, so x1 of 2t. So if x1 of 2t, what should be the mathematical expression and how it will look like? And we will take another example, a1 greater than 1. So this is x1 of 2t, an example. And here we'll take another example, x1 of 0.5t. You can see the scaling factor is in time, not in amplitude. So amplitude, this is the amplitude part. So amplitude is as it is. There is no scaling in the amplitude. There is scaling in the time. So we have two different values, two different kind of values that a1 can assume. Either it can be less than 1 or greater than 1. And for both the cases, how the signal looks like, we will visualize. So x1 of 2t. Can someone say how x1 of 2t will look like? I'm taking x-axis here, that is time, and let's suppose this is y-axis, this is 0. What will be x1 of 2t? So here
One,
t lies between -1 to 1 in the first signal, right? x1 of t. So what will be x1 of 2t?
-2 to
minus 2
2.
to 2.
So here this t is replaced by 2t. Can someone say what will be the time duration between which the signal will exist? Anyway, the amplitude will be 1, right? This will be 1. throughout the duration of time, what will be the time value at the right side, I mean positive side of t?
2.
2.
So we are telling it's from -2 to 2. Is
Yes.
it?
Yes, sir.
So let's check. When we take x1 of 2t, just yeah, is it audible? Hello.
Yes.
Yes, sir.
Yeah, yeah, right.
Yes,
So
sir.
what I was telling is x1 of 2t, we are going to plot the signal x1 of 2t and mathematically express it. So some of you have answered that the time will be from -2 to 2. So let's check it, right? So the first expression, if I uh, write it over here, so this is x1 of t that was given. This signal was having an amplitude of 1 when t lies between -1 to +1, right? -1 to +1, and 0 otherwise. Now, what will happen here? Let's suppose if I write x1 of 2t, what will happen to this amplitude values? Amplitude values will be 1 uh, in which interval, or for which interval of time, or amplitude value will be 0 for which interval of time. So
-2 to 2.
yeah, we will see here, right? So this t is replaced with 2t, right? This t is replaced with 2t. So what we will place is uh, this t is replaced with 2t, right? So if I write this signal, just see it in this way. You write the signal, let 2t is equal to tau. Okay. So what will happen? X1 of tau. So how you will express x1 of tau? X1 of tau, x1 of t is given like this. So x1 of tau is 1 when tau lies between -1 to 1, isn't it? This and this expression is quite similar, only the independent variable t is replaced by tau, isn't it? So the mathematical expression that I have written can be stated below, like x1 of tau is equal to 1 when tau lies between -1 to 1. So what is the value of tau?
2t.
2t.
2t, right? So if I write it as replacing tau by 2t, so x1 of 2t is 1 for 2t lying between -1 to 1, have a 0 otherwise, isn't it? And if I solve it for this interval, what I can write is this value will be 1 when t lies between what value?
-1/2 to 1/2.
Yes. So -1 by 2 to plus 1 by 2. Right? It's not from -2 to 2. Some of you were telling it's -2 to 2, isn't it? So t lies between, if I write x1 of 2t, t will lie between what value? Minus half to half,
Minus
minus 0.5 to 0.5. So let's go to our plot that we have done here. So how it will look like? This was 1, -1, and this was +1, and obviously this point is -5. Right? This yellow color signal, which is from -0.5 to +0.5. So I write it like this. This yellow color signal is x1 of 2t, isn't it? X1 of 2t. And how x1 of t was looking like? Let me plot it in white color. X1 of t was this signal, isn't it? This white color one was x1 of t, which lies between -1 to 1. So the signal, what happened? Scaled in time. The signal was scaled in time. This white colored signal that is represented here in the figure is scaled by what value? By a value of 2. So what is happening? The white colored signal is getting compressed in time, isn't it? It is getting compressed in time. The white colored signal x1 of t, which was lying between -1 to 1 with an amplitude of 1, when scaled in time by 2 times, it is getting compressed in time, isn't it? It is getting compressed in time, that is minus zero point 0.5 to zero point 0.5. Now we will take up another scaling factor and we would like to plot it here. Let's say I will take a blue colored signal and I will write it as x1 of half t, right? X1 of half t. Can someone say how it will look like? X1 of half t.
Sir, between the interval -2 to 2.
Yeah, -2 to 2. So how to find out? So in the same way, like we had written here. So what I will write, is for x1 of, let me put it here. We are interested to find out x1 of half t. So x1 of half t will be for x1 of half t. This together, I'm taking it as tau 1, and the mathematical expression will be x1 of tau 1. So it will be equal to 1 when tau lies between -1 to +1 and 0 otherwise. So this can be written as it is equal to 1. What is this is tau 1, tau 1. So what is the equivalent value of tau 1? Tau 1 is
half t.
half into t, which lies between -1 to 1 and 0 otherwise. So this half t, what we can write? T lies between -2 to +2, right? So in the next expression, if I write, this value is 1 when t lies between this half t, what we can write? If I write t lies between, this 2 will go here, right? This will be -2 to +2 or 0 otherwise. So the signal x1 of t is scaled in time with a scaling factor less than 1. We have taken a scaling factor less than 1, that is half or 0.5. So how it will look like? Let's go to our figure. When someone say x1 of half t, I'm going to plot it in sky blue color, and let's plot this is 1.5. This is 2. This is 2.5. On the negative side, this is -1.5. This is -2. This is -2.5. And we have seen the mathematical expression of x1 of half t, and the expression says that it is from -2 to +2. Right? The sky blue signal that you see, right? The sky blue signal that you see, so the white colored signal x1 of t, when scaled in time by a factor, by a time scaling factor, which is greater than 1, what it is doing to the original signal? It is compressing the signal. When the original signal x1 of t scaled in time with a time scaling factor that is less than 1, it expands the signal, right? The sky blue color signal that you see on the uh, figure happen to be the expanded version of the white colored one, x1 of t, right? So if I take if I say you here three signal expressions, let's say x5 of t uh, that is equal to x1 of 2t, and x6 of t that is equal to x1 of half t. This x5 of t gives us compressed version, compressed x1 of t, right? Compressed version of x1 of t. This gives expanded version of x1 of t. So when the scaling factor is less than 1, the signal gets expanded. When the time scaling factor is greater than 1, the signal gets compressed. This is the conclusion, right? Which I can write in this way. If time scaling factor is greater than 1, signal is compressed. If time scaling factor is less than 1, the signal gets expanded. This you should remember always. This we can do for discrete sequences also. Okay. We will take up an example of discrete sequence in the next class, and we will see that when the discrete sequence like x1 of n, and we would like to generate one more sequence x1 of 2n. So what is happening, and how the things are scaled in index domain, that also we will take up with few examples in the next class. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.